Hello, and thank you for listening to Implications and Significance of Methylmercury in Rice. I am Erin Collins, OMS I at VCOM Carolinas campus in Spartanburg, South Carolina. I'll be presenting today with Tracee Guthrie, Gerline Kaur, and Brooke Benjamin. In this research, we studied the amount of methylmercury in samples of rice bought in Southwest Virginia. This information is clinically relevant due to health detriments that can be caused by toxic levels of methylmercury in the body. The great caloric contribution of rice is significant in many countries throughout the world, which is concerning due to the amount of mercury found in rice universally throughout all samples. The mercury, as I stated, was found in all the samples, leading to our belief that there should be a standard mercury toxicity level that currently lacks in manufacturers currently. We believe that this is a level that manufacturers should be required to stay below. Take a quick look at our summaries for our hypothesis, methods, results, and conclusion. Now when you're ready, click on the heading of each section for a more complete explanation from myself and my colleagues.
Mercury is considered a toxic heavy metal that accumulates in the body, leading to various adverse symptoms. This is particularly concerning due to the fact that it can accumulate in the rice plant, and the rice plant is a staple for many people, including breastfeeding mothers. Mercury is known to cross the blood-brain barrier, which could be harmful to growing infants who are currently breastfeeding. In this slide, we have broken down two topics. Why should you know about methylmercury, and why do we specifically care about methylmercury? We've also added a schematic on the environmental transfer of methylmercury to further explain how it's accumulated in the environment.
So now we're going to talk about our materials and methods. We started this project by gathering 29 rice samples from different locations in Roanoke and Blacksburg, Virginia. The rice samples were chosen based upon where they were grown and produced. They were collected from the following areas: China, Thailand, India, and the United States, with the United States serving as the control. When picking the rice, we made sure not to pick rice that was grown in the same area or that was manufactured by the same company, so that we could, to the best of our ability, gather 29 distinct samples from different locations. The samples were then analyzed using inductively coupled plasma spectrometry, which is an elemental analysis technology capable of detecting most of the periodic table elements at a nanogram level per liter, which for our purposes was converted to nanogram of element to gram of sample. Next, we will discuss how the samples were analyzed.
Here you can see our table of data that includes sample ID, country of origin, amount of mercury found, and the color of the rice sample. The reason country of origin is emphasized in our data is that mining has been shown to increase the mercury content in agricultural soil. Therefore, we hypothesize that countries with more mining would have more mercury, and focus could be placed on this subject area, and people could be advised to choose rice grown in some countries versus rice grown in others. Previous research has shown that increase in soil mercury is correlated with distancing from a mining facility. This is to say that the closer soil is to a mining facility, the higher concentration of mercury will be in that soil. And it has also been shown that the content of mercury in soil directly affects the amount of mercury in crops produced in that soil, which in this case is rice. Rice was chosen for our study as it is a large part of the caloric intake of much of the world, and the way it is grown makes it especially susceptible to absorbing mercury. Thailand has 730 mining facilities. This is the highest concentration when accounting for land mass. The next highest concentration is China, which has 10,000, then India with 3,100, and then the US with 1,400. Our group expected to see that this would correlate with the average amount of mercury found in rice samples. This was supported by some of our research that showed that Thailand produced 7 samples in the top 10 samples with the most mercury content in those samples that we studied. There are also contradictions in our data. All of the samples had a fair amount of mercury despite the country of origin, with China having produced the highest sample of mercury, even though it is not the country with the most mining. This contradiction brings us to our limitations. This point could be an outlier, or this product could have been produced very close to a mining facility. Our limitations were that we do not have enough data to truly say if this was an outlier. Also, we do not know the exact location where the rice was grown, and therefore cannot tell the exact distance from a mining facility. Rice manufacturers were reached out to in our data, and they could also not tell us the exact location where the rice was grown. Other notable findings include that rice that had a darker color to it seemed to have more mercury on average. This confirms some previous findings that processing can reduce mercury content in rice, but this finding could benefit from further research where it is the main focus of the study.
In conclusion, we believe that a wider research should be conducted on more rice throughout the country to get a better understanding of the amount of mercury in rice in general. It's also imperative to provide public education on this topic, as many are not aware of the levels of mercury within rice currently, and that being most pertinent to not only all humans, but specifically to mothers and women who are potentially pregnant. The significance of mercury exposure in foods could lead to a number of health detriments that could also impact pregnancy.